We will be talking about operations with radicals today, and the main thing that you should be able to do after watching this lesson and practicing this stuff is distributing radicals. You guys all know how to distribute. This is that same idea, it's just for throwing square roots, and you got to remember how to use all those properties to multiply different things. So there's one main thing to remember for today, and that's when you're distributing, which is just multiplying. Remember, when you are multiplying, that numbers outside of the radical can be multiplied, as well as numbers underneath the radical. Those can be multiplied. That says underneath, a little sloppy. Okay, so numbers outside the radical can be multiplied, numbers underneath the radical can be multiplied. This is not a new concept. We should have already known this from this unit. That's just the one thing you got to remember when you're distributing radicals today. So all we're going to be doing is practicing. I'm going to do most of them. You're going to try a few. Let me start with number 1 though. So all I have to do to simplify this is just distribute the 3 to both of those terms inside the parentheses. 3 times 2, that's easy. Those are both just plain numbers, so obviously that's just 6. Minus, now here's where radicals come in. When I do 3 times 4 radical 5, I can multiply the numbers that are not sitting under a radical. So that would be 3 times 4, and I'm going to write the whole thing out here. This is what I got to multiply when I distribute the 3 to this term. I can multiply the 3 times the 4 because those are both not sitting under a radical. The 5 can't be combined with anything because it's the only radical number here. So this is what I'm looking at now. And think about last lesson when we were adding and subtracting. They're asking me to subtract these radical terms. Do not say, oh, this is negative 6 radical 5. I actually cannot put these together. These are not like terms. Since 6 does not have a radical 5 on it, I'm done. And this is my most simplified answer, 6 minus 12 radical 5. I'm always going to want to make sure that I take it as simplified as possible. I know that I cannot factor tree down 5. It's not going to go anywhere. So we're going to have to think about that on later problems. But on this one, that would be the answer. All right, let's do another one. This time what we're distributing has a radical involved, radical 5. So let me go ahead and write out longhand, which you won't probably do this in the future, hopefully, but let me write out what actually needs to be multiplied here. So I've got to do radical 5 times 2 radical 2. Let me do that first. So here's what I mean by this above statement. Numbers out front of the radical. So on the radical 5, there's just like a 1 there. So 1 times 2, those can be multiplied together. The numbers underneath the radical, those can be multiplied together. So that'd be 2 radical 10. Over here, since both of those 5s are sitting under radical, I can multiply them and say radical 25. And then I want to see if I can break this down any further. It looks like I cannot add them together at first glance, but we always want to see if we can factor tree to make things better. Hopefully you recognize that 25 is a perfect square. The square root of 25 is just 5. A 5 comes out with nothing left over. Let's use my pink pen here. I can't break down 10. It would just be 5 and 2, so no pairs would come out. But I did rewrite square root of 25 as 5. I cannot add these together because 5 does not have a radical 10 on it, so this is my best, most simplified answer. Okay, I want you guys to try number 3. Maybe watch me do number 4 first, though. The difference on this one is it's 3 radical 2 out front. Number 3 is 5 radical 6. So it's a little bit more complicated what's sitting out front, but the concept is still the same. So when I multiply these two guys, I can multiply the 3 and the 7, the number sitting out front, and I can multiply the 2's underneath. So that would be 21 radical 4, plus when I multiply 3 radical 2 times 4 radical 6, that's going to get me 12 radical 12. Then I want to step back and see if I can make this better. So that means, can I add them together? Can I factor tree the numbers under the radical to make it more simplified? I would look at this and it would jump out at me that 4 is a perfect square. So this one is just 21 times 2. For 12, that's not a perfect square, but I know that, and I should check whether I know or not, but I know that there's a pair of 2's there, so I can bring a 2 out front and a 3 would stay under. So I can rewrite radical 12 as 2 radical 3 right there. And I'm just going to multiply it by the 12 that's already sitting out front of the radical. So let's see, what would it look like now? This would be 42, 21 times 2, plus I can multiply the 12 times 2 and say 24 radical 3. I know I can't add these dice together because 42 doesn't have a radical 3 on it. So as bad as these answers actually look, these are the most simplified forms of the answer. Okay, the ones at the bottom, the next set of 1 through 4, they're the exact same idea. You're still distributing, except you kind of have to foil. And this is something we learned last unit. But again, it's different because we're throwing radicals in. I just think of foiling as like extreme distributing. You're just multiplying two binomials here. So you're going to start by taking the 2 in the first set of parentheses, and you're going to multiply it to both things in the second group. So I'm going to start by doing 2 times 4. Then I'm going to do 2 times 2 radical 5. So bring the negative. I can multiply the 2's because those are both out front of the radical. 5's the only radical number, so I'm just going to bring that down. And then I'm going to multiply or distribute 3 radical 5 to both of these guys. So that would be plus 12 radical 5 minus 6 radical 25. I multiply the 3 and the 2, and then I multiply the 5's underneath. Okay, now I have 4 terms that I'm looking at instead of 2, like the guys up at the top. But same idea, I just want to see if I can put anything together, if I can factor tree anything. So what would jump out at me right away is these terms in the middle. They're both radical 5's, so these are like terms. That means I can add the numbers in front and bring them together. So keep the sign with the 4. This is negative 4 plus 12, which is 8 radical 5's. Don't add the 5's together. This is just me counting how many radical 5's there are. Okay, I brought that 8 down. Over here, I noticed that 25 is a perfect square. That's just 5. So guys, this is really just 6 times 5, which I know is 30. So I'm going to say minus 30. Then I notice, let's see, I can keep going. I can put the plain numbers together. So 8 minus 30, that would be negative 22. And I'm just going to bring down the 8 radical 5. Okay, so there is my best answer. Again, it doesn't look very pretty, but that is the most simplified form of my answer. Okay, I want you guys to try number 2. I'll finish off the 2 at the bottom though. Be careful here. This was a common mistake. It is every year. Last unit you saw ones like this, and people try to distribute the squared. That doesn't work when there's an addition sign inside the parentheses. So you've got to think, what does squared mean? Well, squared means times itself. So you have to write radical 6 plus 5 radical 3. You have to write it twice, and then do what you just did on number 1. So I'm going to distribute the radical 6. And guys, these don't look that bad as problems. They look pretty simple, but there's just a lot of places to mess up. So you just got to work really carefully and slowly. Radical 6 times radical 6, I can multiply those guys and stick that number under a radical. So that would be radical 36. Radical 6 times 5 radical 3. So it's 5 and 1 out front, so that would just be 5. Then I'm going to do 6 times 3 underneath and say radical 18. Then distribute your 5 radical 3. So that would be 5 radical 18 again. On the last term, 5 times 5 would be 25 out front, 3 times 3, 9 underneath. see what you can do to make it look better. I notice in the middle again, those terms are like terms. They're both radical 18s. So I'm going to add those together. That would be 5 plus 5, 10 radical 18. Look for perfect squares. That can happen a lot on these. The square root of 36 is just 6. It's not the square root of 6. It's just a plain 6 if it's a perfect square. Over here, 9's a perfect square. That's just 3. So I really just have 6 out front and 25 times 3, which is 75, lingering at the end there. Okay, I can keep going. I can add the plain numbers together, so that would be 81. And I think a lot of us would accidentally stop here, but you can actually keep going because 18 factor trees down. So I could do like 9 and 2, 3 and 3. You always want to check to see if your numbers underneath the radical can factor tree down. I can rewrite square root 18. I can bring a 3 out and a 2 stays under. Sorry, my work is getting awful. And I would have to multiply the 10 and the 3 out front to say 30. So, okay, here's the best answer. This would be 30 radical 2 plus that 81 there. That's a fun one. Okay, the last one is the same thing. This is one that's like a special case. It's the exact same binomial, except one's plus, one's minus. So something different happens. It's not that exciting. Don't get your hopes up. But I would just distribute the 4. So 4 times 4 is 16. When I multiply 4 times negative radical 10, that'd just be negative 4 radical 10. If you got a radical number and a plain number, you just press them against each other. And we write the plain number first, then the radical number behind it. And radical 10 times radical 10 is radical 100. Okay, in the middle here, here's what's special about this one. These are both radical 10s. Negative 4 plus 4 is 0. Don't even write the radical 10s. They are now gone. I noticed that 100 is a perfect square. It's 10. So this is really just the problem 16 minus 10, which is obviously 6. That was nice. I wish they all kind of worked out that well. Okay, on the back, I want to show you something that's actually an Algebra 2 problem. So you guys won't take Algebra 2 next year, but you'll take it the following year. So be aware that radicals, and I need to mention this to you guys in class, but you literally do all of these radical problems in geometry, like the exact same stuff, and in Algebra 2. So while this doesn't seem like maybe like a useful life skill on every day, it's a super useful math skill. So this stuff isn't going away. Again, this is an Algebra 2 problem. You won't necessarily be tested on it in Algebra 1, but if you can pick this up and follow along with this, that's just a really good sign for Algebra 2, and I'll be super impressed. So if you look at the problem below, why is this not in simplest radical form? If you remember to our fraction lesson, you cannot have a radical in the denominator. And this one has a radical in the denominator. It's got that radical 2 on bottom there. That makes it not simplified. So remember, when that happens, we have to rationalize the denominator. Well, this is different because I have a subtraction problem on bottom. It's not just like a radical 2 and that's it. So to rationalize the denominator here, we must multiply by something that's called the conjugate. It's a weird word. It's an Algebra 2 word. So again, the goal is just to get rid of the radical on bottom. You multiply by what's called the conjugate. So an example of a conjugate can be found on number 4 above, right here. These two guys are called conjugates. And if you notice what happened when you multiply conjugates, the radical goes away. Like I just ended with 6 on this one. There was no radical involved in the answer. So that's the whole idea of rationalizing the denominator here. I want the radical to go away. So if you multiply by the conjugate, the radical does exactly that. So notice what the problem looked like. The conjugate just means the two things are the exact same thing, except one's plus and one's minus. The word thing was very specific of me in that, I know. So the conjugate of 4 plus radical 10 would just be 4 minus radical 10. Notice what happens when you multiply conjugates together. Okay, I just said this. The radical cancels out, which is exactly what I need to happen here if I'm trying to rationalize. So if I were asked, and I'll be asked to do this in Algebra 2, to rationalize the denominator, get rid of the radical on bottom, here's what I would do. I would multiply by the conjugate of the denominator. So I'd multiply it by 5 plus radical 2. The same exact thing you multiply by, just change the sign. Whatever you multiply on bottom, you have to multiply on top to keep it balanced. This is a lot of work. I'm only going to do one of these. I'm going to have you guys try this one, only for the sake of me not eating up another 5 minutes on this video. Again, if you can get this, I'll be super impressed. Maybe even give bonus points if someone reminds me in class. Okay, so here's how I'd multiply this out. On the top, I would just distribute, I'm going to put this guy in parentheses, I would distribute the 7. If you got an addition problem, the 7 has to be multiplied to both of those. So that would be 35 plus 7 radical 2. On the bottom, yuck, I have to distribute the 5 and the radical 2. So there's going to be 4 terms here. 5 times 5 is 25. 5 times radical 2 is 5 radical 2. Negative 2 times 5 is negative 5 radical 2. And then that'd be minus radical 2 times radical 2 is radical 4. If I do this correctly, I should just end up with a whole number on bottom, no radical. Top's not going anywhere. I can't simplify that at all. But let's see if this happens on bottom, what I need to happen. The radical 2's in the middle. 5 plus negative 5, that's 0. So those are gone. And the square root of 4 is just 2. So I really just have 25 minus 2, which is 23. Again, Algebra 2 concept. If you can get this last example by simplifying here, I'll be super, super impressed.